Hello, beautiful people, and welcome. In this video, we're going to be graphing cosine of x with transformations. Now, this is a continuation from the previous video, which is graphing sine of x. So a lot of things were covered in that video. This video hopefully will be a little bit on the shorter side compared to the previous video, which had two parts. I'm going to keep this to one part. We're going to go over briefly the parent function of cosine of x, which is cosine of x. And then we're going to go over the general form and how to apply the transformations, the translation, the horizontal shift, the vertical shifts, and then we'll do that. Now, I do want to mention that this is very similar to how we graphed sine of x, just that it's going to be obviously a different function, so it's going to be cosine. But the way we applied the amplitude, the period, the vertical shifts, the horizontal shifts, all of that is going to be exactly the same. We are also going to be factoring out our b. That is the method we're going to choose. And let's just get started. Again, disclaimer, if you notice any mistakes, errors, please let me know. That way I can learn from my mistakes, and that way you can learn from my mistakes, and that way you don't end up making the same mistake. Also, we are recording from home, so if you hear anything in the background, that is Miss Sylvanas running around being a very happy kitty this morning. All right, let's get started. So let's start with our parent function of cosine of x. So parent function is f of x equals to cosine of x. And then let's graph that out. Now, if you recall in the previous video, we talked about how these values are coming from the unit circle. Again, it's these values here, these points, the location points, 4 of them. Again, technically 5 because we are counting 0 and 2 pi individually. I guess that's the right word. Okay, so this point is located at 1 and 0. This is a 0, 1. This is at -1, 0. And this is at, what is this? 0, -1. Okay, cosine is our x in our points. Oh, excuse me. So it is going to be, our cosine are going to be these values here. And again, what is one revolution or one period? That is 2 pi. So our one period or one cycle of the cosine of x wave or graph will be also 2 pi. Now, some instructors do want you to graph 2 rotations, 2 periods. I only ask my students to do 1 period. So if you can graph 1 period, I am happy as long as you put arrows on both sides indicating that it is a continuous wave in both directions. All right, so we have 2 pi. So what is half of a rotation? Well, half of that is pi. And what is half of that? And that is pi halves. And so this is 3 pi halves. Okay, and then we're going to graph. Now, if you recall the sine of x video, there are 5, technically 4, but technically 5 points that we have that we should be plotting. So let's start with our 2 pi. So 2 pi and 0 are going to be exactly the same value, and that is 1. So right away, that's different. So here's 2 pi, here's 0, that is at 1. So let me actually start already foreshadowing what we're going to be doing today. So that is going to be 1, and then half a pi, or half of that, excuse me, half of 2 pi, which is pi, half of that is going to be at -1. And again, I'm going to foreshadow what we're going to be doing today. That is -1. So already that's different than sine of x. So in sine of x, we have our midline, which our beginning, ending, and middle are all on the midline. In this case, in cosine of x, in our parent function, our midline is still on the x-axis, but if you notice, our beginning and ending are not on the midline, and our middle is not on the midline. So that is the distinct difference from our sine of x wave. So This is our max. This is our min. So beginning and ending are on our max. Again, this is without any reflections. Our min is in the middle. And then, so what do we do with the other two? Well, what is our cosine of pi halves? It is 0. And what is our cosine of 3 pi halves? And that is 0. So what you end up having is you're going to have 2 points in the, 2 points on the midline. You're going to have your beginning and ending on the max, and then you're going to have your middle of the middle. I call that. So complete middle point is going to be your minimum. Again, this is for the parent function, not for anything with, not with anything with reflections. Okay. So what you need to come out of this, knowing 2 points on the maximum, beginning and ending. The middle is your minimum, and you have the middle of between the first 2 points, before the first and the third point, that's going to be on your midline, and between the third and the fifth point, that's going to be on your midline. All right, let's get started with our general form. Just like we did for the other one, let's just call this one g of x this time, is equal to a times cosine of b times x minus h plus k. Again, a is your amplitude. You want to take the absolute value of a. If a happens to be negative, that negative just represents that you have a reflection across the x-axis. Don't take the negative into the account of your amplitude. Just take the numerics. Okay. The b is what you use for your period. So you did 2 pi divided by p is your, divided by b is your period. H again is your horizontal shift. And again, think opposite. So if you see a negative h, your h value is actually a positive h. And your k is your vertical. Again, we are choosing to factor out b. And let's get started. So example number 1. For example number 1, we are choosing to do, what are we choosing to do? Let's do something a little bit on the easier side. So let's do f of x is equal to 3 cosine of x plus pi thirds. And I am actually still going to be looking at my steps from our sine video. Steps are going to be exactly the same. Step number 1 is identify the midline. So what is your k value? In this case, k is 0, so midline is y equals 0, or just on the x-axis. We are identifying your h. Notice that your b first is 1, so 2 pi divided by 1, your period is just 2 pi. 2 pi, too many lines there. So there's nothing to factor out. If your b is 1, there's nothing to factor out. So then therefore h is, again, think opposite, so you see a plus. Therefore h is a minus pi thirds, so we're going to the left pi thirds. And our absolute value of 3 is 3, so amplitude is 3. Now that you have everything, let's go ahead and sketch this out. I have a little bit more room on this side. This is what I'm sketching out. And since I am going to the left pi third times, I kind of learned from my mistake in our previous video that I'm actually going to make enough room on both sides so I don't have to move my y-axis. Okay, so step number 1 is identify your midline. Your midline is y equals 0. Go ahead and put a dashed line there to show that that's your midline. Again, it is not your asymptote, so you don't have an asymptote here. You just have your midline, and this is our way to put a box in where your wave will be. Now, you are going to go to your amplitude. Your amplitude is how much you're going to go up and how much you're going to go down from your midpoint. So this is your distance above and below midline. Okay, so we're going to go above 1, 2, 3, and we're going to go below 1, 2, 3. So this is -3, and this is +3. Okay, next step we're going to do is we're going to identify where our H is. So our horizontal shift is to the left pi-thirds. Negative pi-thirds. Our period is 2 pi. So I need to know from this point, this is 1 pi-thirds distance of 1 pi-thirds. This would be another pi-third, so this is 2 pi-thirds distance. And so this would be a 3 pi-thirds. So then I'm running out of space. So I know I need to kind of condense it a little bit, but I'm trying to figure out my total distance to be 2 pi. So let's see if I can just use a thinking bubble and then figure this out. So let me actually shift this up so you guys can see what I'm doing. Thinking bubble down below. If I start out at negative pi-thirds and I need to go the distance of 2 pi, where will I end up? So I'm going to convert this. I'm going to say this is this is 3. So then this is 6. Right, 2 pi simplifies. So negative pi-thirds plus 6 pi-thirds, that is 5 pi-thirds. So I'm going to end up at 5 pi-thirds. And if that's the case, I'm actually going to make this, can I fit 5 pi-thirds? So this is 1 pi-thirds, 2 pi-thirds, 3 pi-thirds, 4 pi-thirds. I'm kind of going off screen. So yes, in fact, I will make this a little bit smaller. And again, whenever you're graphing, please use an eraser and pencil because it gets messy. Okay, so I'm going to say this right here is negative pi-thirds, something a little bit smaller. So this is, again, we want 5 pi-thirds. So we want, this is pi-thirds, 2 pi-thirds, 3 pi-thirds, 4 pi-thirds. So 5 pi-thirds is going to be here. Now I did write everything out, and I'm going to show you why you didn't have to do that. So 5 pi-thirds is going to be around here. So I know that I'm going to need 5 points. 1, 2, 3, 4, 5, 6. I have too many. So I'm going to erase these. So I know I'm ending at 5 pi-thirds. So the reason I did that is I just wanted to get my distance accurate. And then when I say accurate, I'm not a computer, so it's accurate-ish. Okay, so here's my distance of 2 pi. And then again, if from 0 to 5 pi-thirds, that's 5 pi-thirds. And then I have the distance of pi-thirds. 5 plus 1 is 6. 6 divided by 3 is 2. So in fact, my distance is 2 pi. So now we need, our 5 points. Okay, we need our 5 points. This is where it gets a little bit tricky. Okay, this is where it gets a little bit tricky. You need to know the distance between, let me back up. You know the distance between negative 5 pi-thirds and 5 pi-thirds. We know what that is. We want to know what is half of that distance. So the distance, let me write this down. So distance between, and remember when you're talking about distance, you're talking about absolute values. You don't go a negative amount of distance. You go that amount of distance, but the negative just tells you the direction. So the distance between, we have negative pi-thirds and 5 pi-thirds is you're putting that negative in an absolute value. So you know you have 2 pi, or let me actually rewrite that. So you know you have 6 pi-thirds or 2 pi distance. I want to know where half of that is. So I want a distance of pi. So what does that have to be? That has to be 3 pi thirds because that will cancel out. So negative 5 pi thirds plus what will equal to pi? So I need it to be 3. So that's going to be 2 pi thirds. 2 pi thirds is halfway of the distance. So then these two should be equal. So if I travel pi thirds, 1 pi third, 2 pi thirds, I traveled 3 pi thirds, and then from 2 to 5, that's 3. So I traveled 3 pi thirds in this distance. So 3 pi thirds, 3 pi thirds, both distance. So now I want half of that distance. Okay, so now I want somewhere a point here and somewhere a point here. So I want to know what half of the distance of 2 pi thirds and 5 pi thirds is. So I want a point here, I want a value here, and I want a value here-ish. And again, I'm eyeballing where the half is. So then I'm going to say, let me scooch this up again. Okay, so now again, we're going back to the sine video. I think it was in example number 1 when I said how to find that. So I'm going to say I want to go the distance between 5 pi thirds and 2 pi thirds. I want to know what that distance is. And that distance between them is 3 pi thirds, or just pi. So what is half of that? I want to go the distance of pi halves. That's what I want to go. Well, the distance of pi halves, this right here, it would be a little weird because I have the denominators the same. So pi halves is the same thing as going 3 pi sixths. So I need to know 3 pi sixths is the same thing as 2 pi, is the same thing as pi halves. So I need to add 3 pi sixths here. But again, this is in a fraction and the denominator is 3. So I'm going to say, I'm doing a lot of thinking bubbles. There's a lot of thinking involved in here. 2 pi thirds is the same thing as saying, what is this? 4 pi sixths. Did I do that right? Times 2 times 2. Yes, I did. So this 2 pi thirds is the same thing as saying 4 pi sixths. And I want to go the distance of 3 pi sixths, or the distance of pi half. So then 4, 5, 6, 7, this value is 7 pi sixths. We're going to do exactly the same thing, but this one's a little bit easier since you already know. But let me back up. Let's do the same thing. I want to go the distance of pi halves, right? The distance of pi halves. So I'm going to say, here's another thinking bubble. Pi thirds, negative pi thirds, plus the distance of pi halves. What is that value? So again, we're going to convert. So I have negative 2 pi sixths plus 3 pi sixths, and that is just pi 6. So this value right here is pi 6. That happened fast. Go ahead and rewind, rewatch, and then if it still seems a little hazy, go ahead and keep watching for an example number 2. So now we have our 5 points. Let me again scooch this down a little bit. 1, 2, 3, 4, 5. So now we have to think back of the parent function. I'm thinking more of the points on the parent function. I know cosine is going to be a U shape. I know that cosine has 2 points on the maximum, 2 points on the minimum, 2 points on the maximum, 1 point on the minimum, and then 2 points on the midline. So one thing that I didn't do when I identified where my H is, I didn't mark it off. You don't have to mark it off. I just find it easier to mark it off, especially if they give you a graph instead of you writing your own. Okay, so for a cosine wave, we got the front we've got the first and the last on our maximum line. We got the middle on our minimum. And we got the middle of the middle, that's what I call it, on our midline. The one thing that I did skip is I skipped number 8. I skipped number 8, which says, look if your function is positive or negative. I did do that, but I didn't mention it. So I looked here, is the sign in front of all of it positive or is it negative? If it's positive, then you have a positive function. If it's negative, you have a negative function. Remember, negative just means you reflect across the x-axis. Okay, so now that that's mentioned, let's go ahead and connect. And remember, arrows, it is continuous. Make sure it looks a little bit smooth when you are connecting at the middle. And there you have it. That is your cosine wave for this given function. All right, let's try another one. Let's try another one. Example number 2. And again, we want cosine, so let's do this. F of x is equal to, I'm trying to find a good one, 3 cosine 4x plus pi minus 2. Okay, whenever you see something like this and it is not b is not factored out, you have to factor out. So I have 3 times cosine, factor out that 4, x plus something minus 2. So if you were to distribute that 4, what does 4 have to multiply by in order to get pi? So that's our first thinking bubble for this question. 4 times what is pi? Let's make this a variable, w. So I'm going to divide by 4 both sides. So w is equal to pi fourths. So this is pi fourths. Once you have factored out your b value, let's go ahead and I just noticed we're using 3 again. So let's make this a little bit more challenging by putting a negative out in front. Okay, so our A is our amplitude. So our amplitude is 3. Our B, which has been factored out, is used to find our period. And in this case, our period is pi halves. Now we have our horizontal shift. So H is the opposite of what you see. So it's negative pi fourths. And then your K value is exactly what you see. K is negative 2. Once you have identified that information, and again, you must factor out your B first. Let's go ahead and start sketching this out. I'm going to shift this up so I can get some space. I'm looking at my period and I'm looking at my horizontal shift, and I'm noticing my horizontal is once again in the negative. So I'm trying to find some space. Make sure that I have enough room for negatives. A lot of times you'll be able to sketch something more in the positive direction, but the examples that we've been doing have our horizontal shifts towards the left, and that's fine. Okay, so step number 1 is identify your midline, and that is your vertical shift, so midline. So we're going down to negative 2, 1, 2. That's your midline. Now your amplitude says you're going up and down from your midline this many jumps. So I'm going 1, 2, 3. And again, it's wonderful to have an eraser and pencils. So we're going to extend this out. So 1, 2, 3, 1, 2, 3. And just so we know that this is our midline, I'm just going to go over it with another color. This is our midline. This is our max. This is our min. And by max and min, what I mean is this is our maximum value for the function. This is our minimum function value. All right. Next step, we're going to apply our horizontal shift. So we're going to the negative pi fourths. So if this is pi, I'm thinking if this is pi half. So pi fourths is somewhere here. Pi fourths. And again, we can change that. We are working with a pencil, so we can always erase that if that is not where it needs to be. Now we need a period of pi half. So I know that if I go a full period, where will I be? Well, let's double check. Again, thinking bubble, lots of thought process here. We are at negative pi fourths. We want to go a distance of we want to go a distance of pi halves. Where will I end up? Well, let's go ahead and convert. I have negative pi fourths plus 2 pi fourths, and that gives me pi fourths. Oh, excuse me, 2 pi, is that pi fourths? That is pi fourths. So again, if I'm at negative pi fourths and I want to travel half of a pi, I'm going to end up at pi fourths. And then at this point, I know that I need to squeeze in 3 more points here, and that's going to be a little bit congested. So I'm going to erase these, and I'm going to spread them out just a little bit, just so I have space. And again, wonderful to work with a pencil and eraser, so that way you can make adjustments when you need to. I highly, 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 highly recommend you not using a pen for this. So let's just match the distance here. Okay. So this one, in my opinion, is not going to be too bad. I don't think example number 1 was a little bit more difficult by a lot, in my opinion, because if I'm at pi fourths and I end up in pi fourths, what is half of that distance? And half of that distance is 0. And I shouldn't make any dots here. I'm just going to write 0. And then what is half of this distance? Well, that is negative pi eighths. And what is half of this distance? Positive pi eighths. So definitely a lot easier than example number 1. So go ahead. If you struggle with example 1, shoot me a message, or we can set up a tutoring time. Okay, let's go ahead and that's it. We're done. This is so much easier than the other one. Let's start graphing. So remember, here's our midline. So on a cosine function, we have 2 dots that are on the midline. We have 2 dots that are the maximum, and then 1 dot that's the minimum. Now I am noticing that we do have a negative function, so that means our max and our mins get flipped. Okay, that means our max and our mins get flipped. All right, let's go ahead and start graphing.